Alright. Hi guys. So first of all, welcome to Unacademy JEE English. This is a brand new channel by Unacademy which is India's largest online platform for IIT JEE. And on this channel, everything is being taught to you completely in English. So that no student is feeling left behind because all the major content available on YouTube is in Hindi. Alright, so this is a great initiative by Unacademy. Alright, so it is there to help all you guys who are not very comfortable with Hindi. So this series that I host is for 2021 aspirants, so class 12 students. So I'm taking up topics one by one, and today I'll be discussing capacitors. This is lecture 4 of capacitors. So we had started capacitors, and in capacitors we defined capacitors, what capacitance is. Then we discussed how to calculate the capacitance of various configurations, and then we have been discussing capacitors in circuits, how to find the equivalent capacitances. Alright, so that is what we will discuss today. Also, we will move forward our discussion from the last lecture. Alright, so before we get started, let me introduce myself one more time for those of you who don't know me. So my name is Rohit Dixit. I studied mechanical engineering from IIT Delhi, and I've been teaching physics for IIT JEE for almost 8 years now. And I did all this teaching in offline institutes, and I've worked at some of the most prestigious institutes in the field of JEE preparation. All right, so I myself was JEE rank 447, and in these offline years of teaching, I've already coached many students to top ranks in IIT JEE, and I hope that I can continue to do so with this new opportunity of online teaching with Unacademy for all you guys. So moving forward, let's also talk about the Unacademy subscription and how can that benefit you. In this tough time of lockdown, when you can't go to your offline coachings, I think the online teaching has become very important. It has come up as a great alternative for your studies. You know that this is a highly competitive exam and you cannot waste any time. So how do you really make your online teaching effective? So Unacademy subscription helps you do that. So first you have benefits like live classes. You get to interact with your educators on a regular basis. So that is where the gap of online and offline teaching is getting narrowed. All right. Plus, in classes you have live polls and leaderboards, which make your classes highly interactive. Then you have test series and analysis. All right. So they definitely help you in keeping up with the competition. You get to know constantly where your standing is. You get to identify your weaknesses, your strengths, and work on those. And finally, you have live doubt clearing sessions. All right. So that is also another very powerful feature of the Unacademy subscription. I know you guys really feel bothered about your doubts. I see that every time I take a session, there are so many people who are coming for doubts, and most of the times I am unable to take doubts also in my sessions. All right, but with the Unacademy subscription, when you join the courses there, the live doubt clearing session is a compulsory feature. All right, so after every 3 classes, one class is supposed to be compulsorily for live doubt clearing. So don't worry, this will help you boost your JEE prep by a great leap. All right. So, on top of all these benefits, you are getting access to India's best educators with this subscription. So, Unacademy has got all the top teachers of JEE on a single platform so that every student can get access to them, all right, using this single subscription. Next, so how do you get this subscription? So, it's very easy. You first install the Unacademy app. Once you've installed the app, you go to the plus section, you select your goal as IIT JEE, and you click on get subscription. All right. Now, when you're getting the subscriptions, you can see that the fees has been kept very affordable. All right. Especially if you notice the 12-month and the 24-month subscriptions. These fees are really very affordable, and these fees are nothing compared to the fees that you guys pay in your offline setups or even in tuitions. People pay more than this. All right. So this subscription is definitely worth having for the kind of quality content that you'll be getting for this price. I mean, you shouldn't be missing out on this, definitely. So when you're getting your subscriptions, please remember to use my code RDLive. Alright, so use this code, and this code can make your subscriptions even more affordable. Alright, this is already very, very affordable. You use this code, you get an additional 10% off, and your subscription will become even more affordable. Alright. Okay, so you can also follow us on the Telegram app using the link shown above. Next, without any delay, why don't we start with the topic of the day? Hi Mahendra, how are you? All right. So which class are you in, Mahendra? I hope you've been watching all the other videos. Oh, ninth. That is too young. That is too young. So this is a class 12 topic. I don't know if you'll be able to follow this. So have you already decided? Okay, okay. But capacitors don't do, you don't study capacitors till your class 12th. So this is something entirely uh, different. All right. So have you made up your mind that you want to prepare for IIT JEE? All right. That is great. That is great. Okay. So let's try and talk a bit. Maybe some analogy will help you solve your resistance circuits a lot. Okay. So in the last class, I was talking about symmetries in circuits and how you can use symmetries to solve your circuits. So we talked about three kinds of symmetries that can be commonly seen. So one was axial symmetry, which is along the axis. Another was perpendicular symmetry. Okay, okay, that is great. Okay. And finally, we have reverse symmetry. So what is reverse symmetry? Let's take a look. In this kind of symmetry, the circuit from point A to B is symmetrical to the circuit from point B to A. So if you look at this figure, you will realize. Okay, hello Aksha, how are you? Alright, if you look at this circuit, you will realize this has no axial symmetry. So this is not symmetrical about this, nor is this symmetrical about this. So this has neither axial symmetry nor perpendicular symmetry. However, if you notice, when you're going from A to B, when you're moving in this direction, alright, then what all circuit elements are you crossing? You have 1 microfarad, you have 3 microfarad, then you have 4, then you have 3 and 1. So in front of 1 you have 3, in front of 3 you have 1. How about when you're moving from here to here? You have an exactly similar circuit. Alright. Again you have 1 and 3. Then in front of 3 you have 1, in front of 1 you have 3, and then you have 4 in the middle. So this is called reverse symmetry. Alright. So while going from here, the circuit is identical as it is while going from here. So what all can I say from this symmetry? So the charges on all the capacitors that are placed symmetrically will be the same. So what I can conclude is which one are the charges, which one are the capacitors placed symmetrically. So let's take a look. Okay, so first of all, you have this capacitor, and you have this capacitor. These two are located symmetrically. So these two will have identical charges. Similarly, this capacitor and this capacitor are also placed symmetrically. So these two will again have identical charges. Okay, so that is what you can use, and that will reduce your KVL KCL equations. So I told you we are using symmetries in order to reduce the number of KCL KVL equations that we have to solve. Alright, so here we will be using that fact. Alright, so why don't we take an example and solve this circuit? Let's try and find the equivalent capacitance of this very circuit. Alright, so let's redraw the circuit. So you have 1 microfarad here, then you have 4 microfarad here, then 3, and then 3, and then 1. Alright. So I hope you remember from the earlier videos that how we used to solve this. Alright, so first of all, what are we going to do? So let me just write down the capacitances 1, 3, So this is 1, this is 3, this is 4, this is 3, this is 1. So first of all, we will connect an imaginary battery to it to complete a circuit so that we can apply loop laws. Okay, so let's do that. So I am adding an imaginary battery to it of volt V. Alright, next what I'll do is that I will also make an equivalent circuit. So I will say this is what your equivalent circuit has to be. So your V battery connected to a single capacitor. Alright. Now let's start solving this. So first what we need to do is we need to start assigning charges. Alright, so let's do that. So let us assume that this guy is getting some plus Q1 charge and this guy will get some minus Q1. Again, let's give this person some plus Q2 and this guy minus Q2. Alright. Now from reverse symmetry, what I'll say, if this guy got plus Q2 and minus Q2, what about this guy? This will also get plus Q2 and minus Q2 charges. Alright. And how about this? This will get plus Q1 and minus Q1. Alright. This is what I had told you, that this is how we are going to use symmetries. Now, either I can give this guy a charge of plus Q through Q3 and minus Q3, or I can directly write it also. Yes, definitely, Mahendra. So you seem to be following me still. So now this guy is left. So let's give this a charge of plus Q3 and minus Q3. Alright, so I have assumed these charges. Alright, now what are the isolated nodes that I see? I see this as my isolated node. Alright, so let's mark our isolated node. So this is what I see as my isolated node. So what are the plates connected to this? So I have this, this, and this. Alright. So I know that all the plates that are connected to an isolated node, which means these things are not connected to anybody else. Alright. All these plates are only connected to each other. So what must be the net charge on these? The net charge can only be 0. So that will give me my first equation of KCL. So my equation would be minus Q1 plus Q2 plus Q3 should be 0. So let's write down that equation. So minus Q1 plus Q3 plus Q2 equals 0. That is my equation number 1. Now you realize how many unknowns? 3. So how many equations do I need? Okay, study breeze says 0. Okay, no. Yeah, the sum would be 0. Alright. Alright, so since we have 3 unknowns, we will need 3 equations. Now you realize, had I not used symmetry, then I would have given this guy some Q4 charge, this guy some Q5 charge. In that case, I would have had 5 unknowns. Alright. So that is why I am using symmetry. Symmetry has helped me reduce equations from 5 to 3. So once I have got rid of 2 equations, obviously I'll be able to solve this quicker. Alright, now let's start writing loop equations. Now I hope you remember the rules of writing loop equations. You need to take loops so that every circuit element is counted at least once. Alright, so what are the circuit elements? I have 5 capacitors. Alright, and I have 1 battery. Now because of the symmetry, I don't need to worry about once I have counted any of these. These can also be considered to be counted. Alright, the ones above can also be considered to be counted because of symmetry. So I just need 2 such loops so that both my battery and this guy are also counted. So let's take the first loop to be very simple. Let's start from here and let's move in this direction. So this is the first loop that I'm going to take. So I'm crossing a battery from the negative terminal to the positive terminal. So the potential change would be plus V. Alright. Next, when I move up, let us say I am taking this path. Okay, the path in the above one. Okay, let's use some color to track our path. So let's use this color. So we started from here. Alright, we cross this battery. Then we are moving up here. We go up here. Till now, no circuit element. So till the time no circuit element has been crossed, you don't have to write any potential changes because the potential does not change. Now let's go up and cross this guy. So when you're crossing this capacitor, you're going from the positive plate to the negative plate. So positive to negative, the potential, we are moving from higher potential to lower potential. So change in potential would be negative, and how much will that be? It will be minus Q1 over 1. Okay. So next I will write the next potential change that I encounter is minus Q1 over 1. Okay. Then now let's keep moving forward in a loop. Next I am crossing this again from positive to negative. So what is the potential change that I will encounter? I will encounter Q2 over 3 minus with a minus sign. Why minus? I am going from positive plate to the negative plate. So whenever I am moving from higher potential to lower potential, the potential change would be negative. Alright. So let's write that third term. Third term would be minus Q Q2. Okay. So that was Q2. Q2 over 3. And now again, if I move forward, I come here, and I'm going here like this. So I reach my point back. So I have completed a loop. So this sum should be equal to 0. Alright. That is my second equation. This is the loop equation. Yes, Mahendra. Very good. It is surprising that you are following all this so well already. By the time you come to class 12, you will be an expert in these circuits. Alright, now I still have missed this guy, right? So I needed to cover every circuit element in my loops. So I have covered the 1 microfarad, the 3 microfarad capacitors. So I can say that I've covered these also. I've covered the battery also. The only person left is this. So I need to select a loop so that I can cover this guy also. So I can take any loop. So let's start from here and let's take a short loop only. So if I start from here, I go up, I cross this again. The potential change would be minus Q1 over 1. So let's start writing those. So the first potential change I am encountering is minus Q1 over 1. Alright. Next, when I come here, I will cross this one. Again, this one also I am crossing from the positive side to the negative side. Alright. So from positive side to the negative side, the potential change would be minus Q3 over 4. Okay. So that is the second potential change that I am encountering. Minus Q3 over 4. And finally, I come here and I go back here. Now I'm crossing this from the negative side to the positive side. So the potential would increase. Yes, Mahendra, very good. So potential would increase by Q2 by 3. So the third term that I'll write is plus Q2 over 3. And then what happens? Then I get back to my starting point. So I am getting back to my starting point. So the sum of all these must be 0. Alright. So this is equal to 0. That is my third equation. So I can see I have 3 unknowns of Q1, Q2 and Q3. I have 3 equations. So now why don't we solve this? Alright. So let's use this equation. Let's just multiply everything by 12. So I have minus 12 Q1. So this is equation 3 into 12. I'm multiplying this equation by 12. Why don't we go right down? You could have done that. Where? Where exactly? You have to move in a loop. You can move in a loop, in any kind of loop that you want. Okay, I just picked that loop. I just happened to pick that loop. You could have picked another loop. You can go clockwise, you can go counterclockwise also. Doesn't matter. As long as you're moving in a loop. All you needed to do was find a loop which covers the 4 microfarad capacitor because that one we hadn't covered yet. Okay. I hope that answers your question, Mahindra. Why don't we go right down? After down, you're saying. After here, you're saying why I went here and not here. Okay. So obviously the point is I need to cover a loop. Since I started from here, I wanted to come back here. So the shortest, and I wanted to take the shortest path so that I have a smallish equation. That is just to make things easier. Okay, so that's why I wanted to take a small loop. So smallest loop starting from this point, coming back is going like this, then this, then this, then this. This is the smallest loop. So this will give me the easiest equation. Okay, that was the logic. If I went here and I went here, so I have to come back to this. You realize I am unnecessarily making my path lengthy. Okay, and I will be completing my loop here only, by the way. In any case, that will also work. That will also work, by the way. Don't worry. Don't worry. Even if you moved like that, it would have also worked. Just that it is giving you a lengthier loop, and hence it will give you a lengthier equation. Okay. All right. Great. So let's see what we are getting here. So minus 3q3 plus 4q2 equals 0. So okay, the first equation, let's see, I needed to get rid of, let's say I want to get rid of q1. Oh no, let's say q3. So from here I can say what is q3? Q3 would be 4q2 minus 12q1 over 3. Alright, that is what I can find my q3 as. Now all I need to do is I'll substitute this value of q3 here, okay, in equation number 1. So let's do that. Substitute this in equation 1. Let's see what we are getting. So when we substitute this value in equation number 1, I am getting minus q1. So minus q1, and then I think I had plus q3. Yeah, so plus q3 I will write as 1 over 3 4q2 minus 12q1. Alright, and then I have plus q2. And this is equal to 0. Alright, so let's try and find q2 in terms of q1 now. Alright, so let's simplify this. So let's see what we are getting from here. Minus q1 plus 4 by 3 q2. Then I'm getting minus 4 q1 plus q2 equals 0. So if I take all the q1s on the other side, what am I getting? I'm getting 7 by 3 q2 equals 5 q1. Alright, from here I can say q2 equals 15 q1 over 7. Alright, so this is what I get. Okay, next, now what I can do is I can substitute this value into equation number 2. Okay, so there is some amount of work, as you know, in all KVL KCL approaches. Substitute this in equation 2. Now let's see where that gets us. So okay. So we have already filled this. So let's demark this, and I'm going to continue writing on the other side. All right. So here I had q2 equals 15 by 7 q1. q2 equals 15 by 7 q1. So let's substitute that here. So I get plus 1 minus q1 and minus 1 by 3 into 15 by 7 q1. Alright, yeah, this is what I had. And this is equal to 0. So this and this is 5. So I am getting V equals, okay, so this will be 7, 12. 12 by 7 q1, which gives me q1 as 7v by 12. Okay, so this is a lengthy solution, but you need to follow. Okay, this is one of the hardest problems, in fact, in your circuits. Reverse symmetry is one of the toughest to solve, but pay attention and you should be fine. So I got the value of Q1. Now I can find the value of Q2. So let's see. I know Q2 is 15 by 7 into Q1, right? Yeah. So that is 7 by 12 V. So 7 gets cancelled. This is 5. This is 4. So I'm getting 5 by 4 V. Alright, so I got my Q1, I got my Q2. Now let's pay attention. Now, what is the charge that gets flown from the battery? If a charge Q gets flown and if a charge Q is entering, you can see that Q1 is going here, Q2 is going here. So I can say capital Q, the total charge from the battery is nothing but Q1 plus Q2. And this would be 7 by 12 plus 5 by 4 times V. Alright, very nice. Yes. Alright, so now I can take 12 as my LCM. So what am I getting? I am getting 7, 7 plus 15, that is 22. Yes, 22 by 12. So capital Q is, so 22 over 12 V, which can also be written as 11 over 6 V. Alright. Now, from here, if Q goes here, so what do I know? What would have been C equivalent? C equivalent would have been Q over V. So I know since C equivalent is Q over V, so let's just substitute value of Q here. Therefore, C equivalent would be 1 by V into 11 by 6 V. So this is what I am getting my final answer as. I got my final C equivalent as 11 by 6 microfarad. Okay, so this is how you solve a complicated circuit like this. Okay, I hope you followed the solution. I wish there was a shorter method, but there is none. Unfortunately, this is all the hard work that you will have to do. However, please remember one thing, that because of this lengthy kind of solution, this will never be asked in mains. So reverse symmetry is only important for advanced. If you are revising for mains, when you are revising for mains, then at that time you can skip this. Okay. So please remember this. Let me tell you that this is important for advanced only. It is very unlikely that they will ask you this for mains. Alright, so while you're preparing or while you're revising for mains, so while studying, you should always study the entire syllabus. Alright, so when you are studying capacitors, study them for your board level, your mains level, and your advanced level all at once, because that's the best approach. But while you are revising, when you're revising for boards, then you can only revise that part which is related to your boards. When you're revising for mains, then you can skip these parts which are important for your advanced. And when you are revising for advanced, then pay attention to these. Alright, so this is the approach. Alright, so I hope it is clear. Yeah, Mahendra says yes, that is good. Alright, next we have another special configuration which is called Wheatstone bridge. So this is a special configuration of 5 capacitors as shown in the figure. Alright, so this is what a Wheatstone bridge looks like. So you have 2 points P and Q, and in the middle of P and Q you have 5 capacitors. Okay, this is a standard Wheatstone bridge figure. So you have C1, you have C2, C3, C4, and in the middle of the circuit you have some C5. Okay, so what is the special thing about this arrangement? Let's see. So in this arrangement, the equivalent capacitance between P and Q needs to be calculated. Now in this case, if we take a special case such that the ratio of these two, so the capacitance of this is to capacitance of this is equal to capacitance of this is to capacitance of this, then what happens turns out is that the potential of A and the potential of B becomes equal. Okay, so if this condition is satisfied, so please remember, in case C1 is to C2 becomes equal to C4 is to C3. Okay, please note that I have taken C1, C2, C3, C4 in a circular manner. Sometimes you may be given C3 here and C4 here, then do not blindly use this. Okay, the ratio has to be between these two and these two. Okay, so in such a case, if this ratio, if the capacitances satisfy this ratio, then the potential at A becomes equal to potential at B, and this particular configuration is called a balanced Wheatstone bridge. Now in this, what we can notice is that since the capacitances of A and B have become equal, so what is the potential difference across this? It is zero, which means this guy is not storing any charge. So in this configuration, I can take this guy out, and uh, the simplified circuit is simply this. Alright, so this is very simple to solve now. You have C1 and C2 in series. You have C3 and C4 in series. So you can find this, and this entire combination is in parallel with this. So this would be simpler to solve. So make use whenever you see something like this, whenever you see a geometry, circuit geometry like this, then that is a balanced Wheatstone bridge. Okay. So why don't we take up an example? All right. So in this example, if you solve your H.C. Verma problems, then you can prove this also. By the way, there's a question in which you have been asked to prove such a thing. You have been asked to prove that if such a circuit is given, then prove that these points will have the same potential at under this condition. All right, so you can prove that using your KVL KCL laws. By the way, all right. So the proof is a little lengthy, so that's why I'm not going. Yes, Mahendra, absolutely. So proof is a little lengthy, so that is why I'm not showing that to you right now. We can prove it. Maybe I can later have a question about that, or maybe you can try from KCL KVL. That will give you a practice of KCL KVL also. And if you are unable to do it by your own side, then you can tell me and I will prove it in the next class maybe. All right. So right now, let's just take an example. So I have a situation where I have 5 capacitors like this. Now let's see what is the ratio of this is to this. So 3:6 is 1:2. Similarly, what is the ratio of this and this? 4:8, again 1:2. So since these ratios are identical, so this guy can be completely removed from the circuit. Alright, because this is never going to get any charge. So if I remove this, what is my equivalent circuit now? My equivalent circuit is very, very simple. So I have 3, and I have 6, and I have 4, and I have 8. Okay, this is what my equivalent circuit looks like. So 3, 6, 4, 8. Now this is very easy. Okay, so I know these two are in series. So if these two are in series, what is the equivalent of these? So let's write. So for 3 microfarad and 6 microfarad, let's consider that their equivalent is some C1. So 1 over C1 equals 1 over 3 plus 1 over 6. Now you need to be careful about this. You need to remember that in case of capacitors, the formulae are reversed that of resistors. In series, you apply this formula. In parallel, you add them up. Okay, so do not make that mistake. If you are careful about that, then don't worry, you will be fine. So here will be 6, then here will be 2 plus 1. So turns out C1 is 2 microfarad. So alright, let's talk about this again. How about this combination? Again 4 and 8 are in series. Okay, so 14 by 3. 14 by 3 for which one? For which one, Mahendra? You have told the total or what? So let's imagine that this is C2. So let's try and find the value of C2. So now I can say for 4 microfarad and 8 microfarad, 1 over C2. should be equal to 1 over 4 plus 1 over 8. So which is 1 over 8, here 4 plus 1. So that is C2 equals 8 over 3 microfarad. Alright, yes, Mahendra, very well done. Now you know there is nothing left to be done. Now you know all you have to do is just add them up. They are in parallel, so this is 2, this is 8 by 3. Alright, so since they are in parallel, C equivalent would be the sum of these two. So now, okay, so for C equivalent between A and B, C equivalent would be 2 plus 8 by 3, that is 14 by 3 microfarad. So absolutely well done, Mahendra. You got the correct answer. Alright, so that is how you solve problems like this. Okay, I hope you guys are clear. And Mahendra obviously is clear because he's getting the right answers. Now let's also take a look about a very special case, an infinite ladder circuit. So in this kind of special configuration, you have a pattern of capacitors. Alright, so this keeps on getting repeated. Okay, to form an infinite ladder. So let's see. Here the pattern is you have one here, one here. You have one here, one here, one here, one here. So this will go on getting repeated till infinity. Okay, and you're supposed to find the equivalent capacitance between these 2 points. So let's call them A and B. So you have to find the equivalent capacitance between A and B. Now how do you do it? So now pay attention. There is a trick to this. The trick is, forget about A and B. Look at C and D. Alright. So I am marking 2 additional points as C and D. What happens if I start making the circuit from CD? So let's make a separate circuit. Alright. So this is C, this is C. Okay, so this was C, this was D. Okay. Or let's just take P and Q maybe, so that we are not getting C twice. I don't want the same symbol appearing at 2 places and creating any confusion. So let's treat them as P and Q. Alright, so from P and Q, if I am drawing the circuit, how does it appear? And again it goes to infinity. So what you will realize is that the circuit from P and Q is absolutely identical as the circuit between A and B. Alright, I hope you can see that. So this was my P, this was my Q. Alright, if you will notice that the circuit between P and Q is absolutely identical as the circuit between A and B. Again, because this is going to infinity. Agreed? I hope you can see that. Alright, so let's write down this fact. Alright, since the circuit between A and B is identical to the circuit between P and Q. Or what can I say? That if equivalent capacitance C equivalent between A and B equals some, let's use some symbol C0, then C equivalent between P and Q is also C0. Alright, now I will make use of this fact. Now how can I redraw this? Instead of this entire circuit between P and Q, I can replace this with a single circuit which has an equivalent capacitance of C0. So now I can say that, so thus we redraw the circuit Thus, we can redraw the circuit as I can say now this is okay. So this is 1C. Then there is another C here. Okay, so this is A, this is B, and this is one C naught. So I'm calling this C0. This is C, this is C. Agreed, I can redraw this like this. I hope you followed the logic. Just follow the logic. Alright, just follow the logic. Is this making sense to you? That if the equivalent capacitance between A and B is C naught, then that between P and Q will also be C naught because there is no difference in these two circuits. So now what I'm doing is I am making this circuit as this. Great. Alright. Okay, so now how do I solve this? And now I can solve this very easily. I know C naught and C are in parallel. So the equivalent circuit would be, so let's draw the equivalent. The equivalent would be C, and then I have single, which is C plus C naught, and then I have B. Alright, next, since these two are in series, their equivalent would be equal to the equivalent between these, which is again C naught. Oh yes, Mahendra I think is giving me the answers already. Oh, that is great. So now I can say that 1 over C naught would be equal to 1 over C plus 1 over C plus C naught. Alright, alright. That is amazing. So let's start taking the LCM. So what do you get? 1 over C naught minus 1 over C plus C naught equals 1 over C. So here I can say C plus C naught minus C naught over C naught times C plus C naught equals 1 over C. So from here I can do this, and if I cross multiply, what am I getting? I'm getting C square equals C naught square plus C naught C. So I'm getting a quadratic equation, C naught square plus C naught C minus C square equals 0. So since I'm getting a quadratic equation, I know how to get the roots. I know from here that C equals, okay, so minus B, which is minus C, plus minus square root of B square, which is C square, plus 4AC, so that is 4C square, over 2A, that is 2. Now remember one thing, the capacitance can never be negative. It's a positive quantity always. So I will ignore the minus sign and I will have this C naught. So C naught equals C equivalent, which is, so this is, okay, so take C common, root 5 minus 1 over 2. Okay, okay, okay. So it is root 5 minus 1, Mahendra, not minus 2. Okay. Or have I written it wrong somewhere? Okay, so this is how you solve this. Okay, why don't I give you a variation of this? So why don't you try this? Okay, find the equivalent capacitance between points x and y as shown in the figure. So practice this problem. Okay, so please practice this problem, all you guys. All right, let's see if we can solve this. All right. I hope everyone's trying this. So this will be very, very simple. This will be done exactly the way we solved the last problem. Okay. This is slightly different though. Okay, this is slightly different. This is not exactly the same. Please note that. This is not exactly the same. Okay. This is slightly tricky. Okay. No. This is actually the same. Yeah. All right. So Mahendra is getting the answer as 2. So let's see if that is correct. This is x. Then you have 1. Then you have 2. Then you have 1. Yeah, 2, 1, 1, 2. Okay. So 1, 2, 1, 2, and so on. Alright, I hope I got this correct. Yeah, 1, 1, 1, 2, 2, 2. Alright. So now, yes, you can say that if you have x and y here, you could have marked some other points. Let's say A and B here. And absolutely, you could have said that equivalent capacitance between x and y would be equal to the equivalent capacitance between A and B. Hi, Chinmay. Let me just check it. Hi, Chinmay. I wanted to tell you that yesterday I think there was a problem with my settings in the special class on the app. Okay, so I am new on the app. This is the third class that I took on the app. I am good, Chinmay. So I think I think in one of the polls I had switched off the chat, and after that, when I enabled the chat, I don't know, I pressed some wrong button because of which I was not getting any messages. Alright. So what happened was all I could see was emojis. And I thought maybe nobody is writing in the chats. Later when I saw the video again, I realized, okay. So I'm so sorry, that is why I could not respond to you. Okay. Because I was not getting any messages. I mean, you can imagine that is why I did not respond to a single message because I wasn't getting any. Otherwise, I would have definitely responded because I saw the video later and I realized people were desperately asking me questions. And of course, I would have responded if I could see the messages. So let's redraw this circuit here. So I'm saying let's assume let the equivalent capacitance between x and y be C. Yeah, I know. I saw that in the when I watched the video later, so I saw that and I felt really bad that I could not respond to anyone just because I never saw any messages. And I'm sure most of you guys were feeling a lot frustrated because I wasn't responding to any of the messages. But that was because I never saw any messages. Okay, I'm sorry. I mean, that was. You should have realized that how can I not respond to any message? I wasn't getting any message. So I can say if the equivalent capacitance between x and y is C, then the equivalent capacitance between A and B will also be C. Alright, so now I can redraw this circuit as this, and I can add C here. So this is what my new circuit would look like. So this is 2, this is C, this is 1. Alright, so now what is the equivalent of this? Again, these are in parallel, so equivalent of this would be 2C over C plus 2. Alright, so now I can draw this again. So this is 2C over 2 plus C, and this is 1. So now I know the answer. The equivalent capacitance between X and Y, which is also C. So I can say that C equals 1 plus 2C over 2 plus C. Alright. So now all I need to do is take these on the other side. So let's see what I am getting. So C minus 2C over 2 plus C equals 1. So I am getting from here 2C plus C square minus 2C equals 2 plus C equals 1. So yeah, this is getting cancelled. So what I am getting is, I am getting C square minus C minus 2 equals 0. So I cross multiplied this, and then I took all the terms on the one side. Okay. Now it's very simple. C would be plus 1 plus minus 1 square plus 8 over 2. So I will obviously ignore the negative because capacitances can never be negative. So I can rewrite C as 1 plus 3 by 2, that is 2 microfarad. So yes, absolutely right, Mahendra. It is awesome to see that you are solving these circuits. Trust me, a lot of class 12 students have problems solving these circuits. So good to see you going at it so great. Okay. Now also find the equivalent capacitance between points A and B here. So what will be the equivalent capacitance here? Let's see. Alright, practice this. Alright. Come on, let's try and get an answer for this quickly. Now I know Mahendra must be aching to quickly answer this. It is good to see so bright students and studying right now only in finished class 9th and solving class 12 problems. So I think you have a very bright future ahead of you, Mahendra. I really hope you can make the most of the rest of the time. So good luck. Alright, this should be simple. Is anyone trying? Please write trying if you're trying this. Alright, please write trying in the chat in case you are trying this. Yes, 3 by 2 C. The answer is 3 by 2 C. Very well done, Mahendra. So 3 by 2 C, that is the answer. This is a balanced Wheatstone bridge. Okay, this is a balanced Wheatstone bridge. So this is to this is equal to this is to this. So you can simply remove this. So then there is nothing. Okay, you simply have you simply have 3cc, 3cc. So any one of those, the equivalent of this would be 3c by 4 Now both these are parallel. So yes, C equivalent would be 2 into 3C by 4. That is 3C by 2. That is the correct answer. Alright, very well done. So why don't we try another problem then? Okay, how about this? You find the equivalent capacitance between points A and B for this. Okay. Let's see if you can solve this. For education says, sir, in XT graph एक टाइम में दो पोजीशन क्यों नहीं हो सकता है? Please help. I am unable to write in English, so I wrote in Hindi. Oh, that's fine. Uh, okay, so what does it mean that you have two positions in one time? That you are at two places in one time. Can you be in two places at one time for education? In physics, it is not allowed. In physics, you can't be in two positions at one time. Okay, that is why. Yes, so that is why. That is why you cannot have two positions at one time. Okay. Got it? See, if the xt graph was like this, so this is your x, this is your t. If I have made a graph which was, let's say like this, so that would mean at this time you are here also, you are here also, which is impossible. Okay, you can't be at two places in one time. I mean, unless you are probably God. Okay, so except for God, we treat that in physics, nothing can behave like that. Okay, so that is why that graph is not allowed. Alright, so Mahendra says 5 microfarad. Let's see. Okay, so you had, let's see what the circuit was like. Okay, so A, then 2, 2. Okay, so you had A, then you have 2, then you have another 2, then you have another 2. Alright. $12 and then B. Okay, so all you need to do is start marking the potentials. So 2, 2, 2, 12. Okay, so this is 2, 2, 2, and 12. So let's start marking the potentials. And I had told you that if, as long as we are moving along a resistless path, the potential doesn't change. So if this is A, this would be A, this would be A, this would be A. Alright, if this is B, let's call this some D. I'm not using C because C we usually use for capacitances. Alright, now all I need to do is redraw this circuit in a simplified form. So from 1, starting from A, how many plates you have connected to A? One here and one here. So from A, I will make 3 capacitors of 2, 2, 2 each. Okay, so that is what I'm going to do. So I'm going to start from A and I will make one capacitor here, one capacitor here and one capacitor here. So all of them are of 2 each. Alright, now let's see. These two have one plate connected to A and another connected to D. So these two here, let's connect their ends and let's call this D. Alright, so now you see these two will have one plate connected to A and one plate connected to D. Now from D I have one capacitor of 12 going to B. So from D I have one capacitor of 12 going to B, and this is also B because the other end goes to B, so I can join these. And this is finally what my circuit is looking like. Okay, so now it is very simple. I can replace this by 4. Alright, so now I can make A now only 2, 4 and 12 and 2. So this is 4, this is 12, this is 2 and this is B. Okay. Okay. So what is the equivalent capacitance of 4 and 12? So let's see. Let's see what is the equivalent capacitance of C equivalent for 4 microfarad and 12 microfarad in series. So this is nothing but 4 into 12 over 4 plus 12, so that is 16. So yes, 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 so 3. Absolutely, 3 microfarad. Now all you have is 3 microfarad and 2 microfarad in parallel, so obviously the C equivalent between A and B. Therefore, C equivalent between A and B equals 5 microfarads, which is absolutely right. I think that is the answer that was given by Mahendra. Yes, Mahendra, so you seem to have become the expert of this already. Very nice to see. Alright, next let's talk about connecting two charged capacitors. So, okay, so we are I think done with the circuit solving. This is everything that I wanted to tell you about circuit solving. Alright, so you can use Kirchhoff's laws, you can use symmetries, and you can use your normal series parallel combinations by marking the potentials at different points. Alright, next let's talk about connecting two charged capacitors. So what you're doing here is that you have two capacitors which have been charged previously, and now you're bringing them together and connecting them to each other. Then what do you do? So when two charged capacitors are connected to each other, then the potential difference across both of them will become the same. So imagine there was this one guy which had capacitance of C1, initial charges of plus Q1 and minus Q1. And you had this other capacitor which had a capacitance of C2 and charges of plus Q2 and minus Q2. Now, plates are conducting plates. So what happens when you connect those two? Whenever you connect those two, the two plates would come and on the equal potential, will gain the equal potential. So whenever I am connecting C1 and C2 like this with wires, you realize that potentials of this plate and this plate would be equal. Potentials of this plate and this plate would be equal. That is why the potential difference here and the potential difference here both would be equal, which will be equal to some delta V. So that's the first thing that I'll notice, that whenever two such capacitors are connected, the potential difference across both will become the same. Now charges from both will flow, okay. So charges will flow and redistribute themselves over them, and such that the total charge can only remain this. So let's say that you had some charge Q1 dash here and minus Q1 dash here, and you had plus Q2 dash here minus Q2 dash here. So all you need to know is that the total charge cannot change. So you can write two expressions. You could have written that Q1 dash over C1 equals Q2 dash over C2, and Q1 dash plus Q2 dash equals Q1 plus minus Q2. Why am I writing plus minus Q2? Because I don't know which plate was connected to which plate. Maybe the positive plate was connected to negative plate. Maybe the positive plates were connected together. So I could have either connected them like this. This simple way. Right. Or what I could have done was I could have connected the positive to negative and negative to positive. So the other way I could have done this is I could have connected these two and I could have connected these two. Alright. So I can connect positives together, negatives together, and I can also connect positive and negatives together. So depending on that, the total plate on these isolated plates. So in this case, if I connected positive and positive, the total charge on these two plates would be Q1 plus Q2. If I connected positive to negative, then the total charge on this and this would be Q1 minus Q2. So I can use these equations, these two equations, and find the values of Q1 and Q1 dash and Q2 dash. Once I have that, I have the common potential also and the new charges also. So those are this. That is what is asked in such problems. You are asked to find the common potential once these are connected together, and you're asked to find the new charges. All right. So please remember that connections may be made in two ways. One, both plates are having similar charges are connected, and another opposite. Both plates having opposite charges are connected together. So you have to pay attention to that. All right. So why don't we solve a problem and see if we understood what we just talked about? So here you've been told two conductors of capacitance. Okay, so two capacitors. Let's write two capacitors. So two capacitors. So two capacitors of capacitance 1 microfarad and 2 microfarad are connected, are charged to 10 volt and minus 20 volt, and they are now connected by a conducting wire connecting the plates with similar charges. Find A, their common potential, B, the final charges, and C, the loss of energy during redistribution. Hi Manjul, how are you? So give this problem a try. Remember what I just told you, that the potential would be same and the net charge would be the same. Alright, so use conservation of charge, use the fact that these two capacitors would acquire a common potential. Okay, you will get two equations, you have only two unknowns, you will be able to solve this easily. Okay, so what class are you in, Manjul? Sorry, I forgot. What class are you in? Alright, I hope you guys are trying this. Please write trying in the chat so that I know you are trying. Please write trying in the chat so that I know you are trying. Okay, Manjul, so you are in class 11th. Okay. So this is a class 12 topic, by the way. Okay. So I hope you're following my class 11th series regularly. That is on Mondays, Wednesdays, and Fridays daily at 4. Okay, Mahendra is quick to give all the answers. Wow, that is great. Okay, minus 10 volts. I will have to check Mahendra. I don't remember the answers. Alright. Okay, great. Alright. I hope others are also solving just like Mahendra. Maybe Mahendra is making everyone feel intimidated. Mahendra has just finished class 9th and he's solving problems of class 12th. So I guess that is why nobody else is answering. They are scared of Mahendra. It is wonderful to see that you're giving the answers. Okay, how okay, you're telling me minus charges only. Okay. Oh, that is fine, that is fine. So, by the way, whenever you say the charge, you only give the magnitude. Okay, because think about this. If one plate is getting positive, then other plate would be getting negative. So I hope you realize if this plate is getting negative, then this will get positive. So you always mention magnitude in the charges. Okay, never say negative. So if I ask you what is the charge on this, so if this has plus 5 microcoulomb, and this is minus 5 microcoulomb. What is the charge on this capacitor? We say it is 5 microcoulomb. Yes. We only say the magnitude because the net charge is always 0 on any capacitor. Okay. Alright, so okay, let's see what Mahendra did. So you have two capacitors of 1 microfarad and 2 microfarad. So here C1 equals 1 microfarad and C2 equals 2 microfarad. Okay, and what was V1? So V1 I think was 10, V2 I think was minus 20. Okay, V1 was 10 and V2 was minus 20. Alright, that is interesting. Okay, now please pay attention. What does the language say? The language says that the conducting wire connects the plate with similar charges. Okay, with similar charges. So please remember this. So let's try and find the charges on each. So what are going to be the charges on C1? So I can say Q1 is going to be C1 V1. Okay, so that is 1 into 10. So 10 microcoulombs. So you will have plus 10 microcoulombs here and you will have minus 10 microcoulombs here. Alright. How about on the other one? Other one it would be C2 V2. Which is 2 into 20, that is 40 microcoulomb. Now please note what is happening. What is happening is that I am, okay, here it might be minus 40 microcoulomb and here it might be plus 40 microcoulomb. Now please note what has been said in the language. That the conducting wire is connecting the plates with similar charges. So how are we taking our wires? We are taking our wires slightly twisted. We are connecting this with this and we are connecting this with this. Okay. So please remember that. So if the new charges, let's redraw this. And now I'm just making the wires simple only. So let's say that C1 and C2 were charges of plus Q1 dash, minus Q1 dash, plus Q2 dash, minus Q2 dash. So what I can say is Q1 dash plus Q2 dash, Q1 dash plus Q2 dash equals this plus this. So that is 50. Also I could have said that Q1 dash over 1 equals Q2 dash over 2. Why? Because the potential difference across both would be the same. Alright. C2 I think was 2 microfarad, right? Yeah. So from here I can say that Q2 dash equals to Q1 dash. Substitute this here, I get 3 Q1 dash equals 50. So I am getting Q1 dash equals 50 by 3. Okay. So I think you made a mistake there, Mahendra. You did not follow the fact that plates with similar charges were connected. I think you connected positive to negative. Alright. So that is why you're getting the wrong answers. Alright. So now, for potential difference also we only mention magnitude by the way. So once I know this, what is the common potential difference? Common potential difference V would be equal to Q1 dash over C1, which would be 50 over 3 volt. Alright, so that would be the common potential difference. And the charges are so Q1 dash equals 50 over 3. How about the Q2 dash? Q2 dash is 2 times this. So 100 over 3. So microcoulomb and microcoulomb. So first two answers are sorted. Next, loss of energy, that is very simple. Find the initial energy stored, find the final energy stored. So initial energy stored would be half C1 V1 square plus half C2 V2 square. So U initial energy would be half C1 V1 square. So half C1 V1, C1 was 1 into V1 was 10 plus half C2 to V2 square. So that is 400. So initially initial energy was this is 450 microjoules. Alright. What is the final energy? Finally, final is, I know the common potential difference, I know the net capacitance because these are in parallel would be addition of this. So net capacitance would be 3. So final would be C1 plus C2 V square. So that would be half into 3 into the common potential I found as 50 over 3. So that will be your answer. So U final I'm getting 1250 over 3. So let's roughly write this as, this would be around 420, 418 or maybe 417, around 470. Alright, so loss of energy would be the difference of these two, that would be 33 joules, microjoules roughly. Alright, I hope everybody followed that. Yes, that is alright. That is alright. So the loss of energy is roughly about 33 microjoules. Alright, this is how we solve this kind of problem. Now, another class of problems that you will encounter with capacitors is you have to find the capacitance of a system of parallel plates. So you're given a lot of parallel plates and they are connected to each other and you're supposed to find the capacitance of this system. So in this class of problems, an arrangement, okay, so in this class of problems, there should be a comma here. An arrangement of parallel plates is given and we are supposed to find the equivalent capacitance between 2 points. So what do is, in such cases, we start marking the potentials of different plates and we finally draw a simplified capacitor circuit. We finally solve this circuit to find the equivalent capacitance. So let's take up an example. This is what your question will look like. You have 4 plates here, the 4 plates are connected together. Now you are supposed to find the equivalent capacitance between A and B. So how do you do it? You start marking the potentials on different plates. Then you finally draw a simplified capacitor circuit, then solve that circuit to find the equivalent capacitance. So let's see what I am trying to say. So let's talk about this question. In this question, you've been told that the figure shows 4 parallel plates kept at equal separation, forming 3 capacitor plates, parallel plate capacitors. So which 3? You have one here. So this is number 1, this is number 2, and this is number 3. These are the 3 parallel plate capacitors that these 4 plates are forming. And you've been told the capacitance between any 2 adjoining plates is C. So all of them are C only. So alright, so every capacitance is C. Alright, next what has been told to you is to find the equivalent capacitance between A and B. Alright, so let's try this. So this is what you have. So as I told you, first what you do is you start marking the potentials. So okay, if this is A, this side of the plate would have A because this is connected to A. This side of the plate would also have A. Okay. Similarly, this side would have A, this side would have A. I hope you can see that. So everything that is connected to A will have potentials of A. Now, similarly, everything that is connected to B will have potentials of B. Now let's talk about the three capacitors. So this is one capacitor between A and B. This is one capacitor between A and B. This is another capacitor between A and B. Now I can redraw a simplified diagram of this. And so what do? I will start from A, and I know from A how many capacitors? 1, 2, 3. So I will draw 3. Alright. And all the other ends of these capacitors are connected to B. So this is what my simplified circuit looks like. This essentially, the thing that is given to me above, this is nothing but this. Alright, now it is very, very simple. I can say what my equivalent capacitance is. C equivalent obviously is 3C. So that is my answer. That is how you can solve these. Now this problem is, again, this kind of problem are very, very important for your JEE. A lot of times these kind of problems have been asked both in mains and advanced. Alright, so please pay attention and please make sure that you are comfortable with this. So go through what we just talked about. We started marking the potentials. Alright, it is very, very simple. Then all we needed to do was redraw a simplified diagram. Once I have a diagram of my circuit in this form, it is very easy to solve. Alright, I hope you followed it. Yes, 3 epsilon naught A over D, that is correct. But here I was already told that the capacitance between two adjoining plates is C, so I just wrote 3C. Okay. Okay, why don't you solve this? So this is a practice problem. So you seem to be getting a hang of this. Very good. So figure shows 6 parallel plates shown as kept as shown. You have to find the equivalent capacitances between plates A and B. Alright. So let's try and find this. Okay. Let's see. Alright, by the way, I don't really remember the answer, so you'll have to wait for me to solve. Okay. I'm sure Mahendra will give the right answer though. Because Mahendra has been giving almost all the answers correct so far, which is amazing. Alright. So just write trying in the chat so that I know you are trying. So that I know I have to wait for some time. Okay. Mahendra, are you trying this? Okay, so there is no response from Mahendra, so why don't I just start solving this? Maybe he's trying, maybe he's too busy practicing or trying this. Alright, so as we had discussed, how do we solve this? We start marking the potentials. So first of all, what we need to do is mark the potential of this as A, this as A. Alright, so this is all that is connected to A. So I'm done with this. How about this? This I can mark the potential of this plate as B, this plate as B. Now this plate is connected to this plate also. Alright. Alright, no problem. So since this plate is connected to this plate, the potential of this plate and this plate would be the same. So I can mark B here and I can mark B here. Alright. So that is what I'm doing. I mark A and B. Now the point is I have marked A and B. I don't have any more A's and B's. Alright. So what do I do next? Next I start marking some more. Alright. So I'm going to avoid marking something with C and D, because C and D I can already see would be variables here. So let's start marking P, Q and so on. So I don't know the potential of this. So any unknown, I would assign it a number. So let's call this P. I will assign it a variable. Okay, if I don't know the potential, I will just start calling it some P. So if this is P, then I can see that this plate is connected to this. So this will be P, this would be P. Alright. I hope you can see that. If I assign P to this, P potential to this, then the potential of on these two sides will also be P. Alright, now I have got the potential on this, I've got the potential on this, potential on this, potential on this, potential on this. This is still unknown. So let's write some Q here and some Q here. Both the sides of the plate will have the same capacitance Q. So now I have marked the capacitances of all the plates. Alright. So now let's try and draw a simple circuit. Now, how many capacitors do I see? I can see one here. Let's call this capacitance C. Alright, then this is also C, this is 2, this is also C, this is 3, this is C by 2, this is 4, and this is also C, this is 5. So I can see 5 capacitors, and I have written the capacitances of all C, 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 C by 2 and C. Why? What was the formula for C? C is equal to epsilon naught A over D. So if this is C, this is also C, this is also C, and this however becomes C by 2 because the distance is 2D. Alright, now let's try and draw a simplified circuit. Alright. Okay, so Mahendra says 11 by 7. Yes, that may be the correct answer. I don't really remember, but I think that may be the correct answer. So anyways, so how many capacitors are connected to A? So I can see that this and this. So two capacitors are connected to A, both of C capacitance. So I'll start from A. I will join two capacitors of C each. So this is C, this is C. Now this end of the capacitor would be B. So let's write this as B. How about this end? This end is connected to P. Alright, so this is P. Now what else is connected to P? So these two are also connected to P. This goes from P to Q. Alright, this is going from P to Q. So from P also I need to connect two more capacitors. One this one. Alright, this one. And one this one. I hope you can see that. So from P I will start two more capacitors. Okay, one of C, the C1 is going to B, so this is B. One of C by 2, what is C by 2 going? C by 2 is going to Q. Alright, now from Q I have another capacitor C, which is going to B. Alright, so here we have, this is B, this is B, this is B, so all of them can be connected together. This is what my simplified circuit will look like. I had 5 capacitors, here I have drawn 5 capacitors. Okay. Please take a look at what I did. Yeah, no problem, no problem. It's a matter of practice, Mahendra, you will get better at it. So what you did was you started marking the potentials. Alright, so once you mark the potentials here, so this was A, this was A. And I saw that nothing else is connected to A. Then I started marking for B, okay, and let's see. So if this was B, this was B, now this plate is connected to this plate, so that becomes B and that becomes B. Alright, so these are all the A's and B's that I have. Now I don't know what else to do. So whatever unknowns are left, I will start randomly assigning them potentials. Alright, so I can assign this guy. I randomly assign this guy some potential P. Now because this is connected to this will also become P, this will also become P. Now I know that one capacitor is between A and P, one is between A and B. I still don't know the potential of this, so I will assign it a further number. I am assigning this Q, so this also becomes Q. Alright, so I hope you can see that. This is me just marking the potentials randomly. Wherever I see connected plates, I start marking the potentials. Now I start looking at the circuit. Now I know I have to start with A. So starting from A, how many capacitors do I see connected to A? One, this one. Okay. So one is this between A and P. One is this between A and P. No other capacitor connected to A. So I start from A and I made these two capacitors. And the one end of capacitor is made B and this end is called P. Now I see from P what is happening. From P what else is connected. So one was this guy, we have already drawn this capacitor that was connected to P. If we come down, then there are two more capacitors which are connected to P. So from P again I made two more capacitors. So one here, one here. Now one guy is connected to B between P and B, another is connected between P and Q. So what is the capacitor between P and Q? P and Q is the C by 2. So I draw a C by 2 and I mark this end as Q and this end as B. So C is connected between P and B. C by 2 is connected between P and Q. Okay, I hope you guys are following this. Then from Q I have one other capacitor C which is connected between Q and B. Right, so I mark this also B. Now I have this B, this B, this B, all these are B, which means all of them can be connected together. So I connect them together and finally I close the circuit and this is what my circuit looks like. Alright, now I can simplify this. This is very easy for me. This is just the regular circuits that I'm used to. Alright, so I know that these two are in series. So these two being in series, what is the equivalent capacitance here? Okay, so let me redraw this, maybe here. So I have A, starting from A I have two capacitors. Alright, so these were C each. And from here I have two. One is C and C by 2. So C and C by 2. C and C by 2 in series. What will that be? That will be 1 into 1 by 2 over 3 by 2. So that will be 1 by 3. Okay, that will be the capacitance of this. C and C by 2 in series would give C by 3. You can solve this and check. So from here I have two which are C by 3 and C. Okay, so you have C by 3 here and you have C here. And that is it, I think. Yeah. This is what it looks like. Right, now I know these two will give me 4C by 3. So I can make it like this. C, 4C by 3 and C. So this is C, this is 4C by 3 and this is C. Now C and 4C by 3, how much does that make? Let's write. This is C and 4C by 3. So for C and 4C by 3, C's. If C1 and C2 are in series, then C equivalent is C1 C2 over C1 plus C2. Right, that is what I keep doing. So I thought I'll just mention it. So what will be this C equivalent? C equivalent would be 1 C common times 1 into 4 by 3 over 1 plus 4 by 3. 1 plus 4 by 3 is 7 by 3. So this 3 will get cancelled and I will get 4 by 7C. Alright. Now it is very simple. It is 4 by 7C plus C in parallel. Okay, so yes, Mahendra had given the correct answer. Alright, so this is A, this is B, this is 4 by 7C, this is C. Obviously C equivalent would be the sum of these two, which is 11 by 7. So final C equivalent equals 11 by 7C, and C was epsilon naught A over D. So yes, that is your correct answer. Alright, very well done, Mahendra. Forget about you taking more time. I'm just surprised that you got this right. This is supposed to be one of the toughest problems. Alright, that is it from my side, guys. It's always good to see someone be able to solve all the problems that I'm giving you guys here and follow all the theory that is being taught here. So wonderful to see that. Thank you for your wonderful participation, Mahendra. I hope that you keep participating in all my lectures like this and keep doing all the questions correctly like this. Alright. So that is it for today. I will wrap it up here. And before I leave you, let me tell you that you can get your Unacademy subscriptions uh, following these steps. You go to the plus section, you select your goal as IIT and you click on get subscription. Alright. And when you're getting your subscriptions, please note that the fees is very, very, very minimal. Alright. And at these fees, I think this subscription is a must have. You cannot miss the quality content that you'll be getting here for this price. And when you're getting a subscription, use my code RDLive, so that code will make this subscription even more affordable by giving you another 10% off. So if you like this video, if you thought you learned something new, if you got more practice, then press the like button and share it with your friends. Also press the bell icon to receive notifications of all the lectures that are happening on JEE English channel. The PDF of all the slides used would be available by tomorrow for download. Alright. Now you can join us on the Telegram app using the link shown above. And please remember before I leave you that you can get your Unacademy subscriptions using this code. This is RD Live. Use this code to get additional 10% off. Alright, so I'll see you guys next on Monday. 12th guys on Tuesday. Alright. So yes, take care and bye bye. Bye Hitesh.